Bismillahirrahmanirrahim. Today we have a BCD to 7 segment display decoder explaining. Uh, First of all, the description of our project is this project is about designing a digital circuit that converts a 4-bit binary coded into the correct signals of light up a 7 segment display. So we have a 7 segment display and we should light up the right light. A BCD input represents the numbers 0 to 9, and we should know our number and use the circuit to write the right number. The main goal is to create a logic circuit that takes a 4-bit BCD input, output the correct pattern to a 7 segment display. We can display digits from 0 to 9. That's what we can do. So what we did, we created a truth table. I will show you up for input and output. We used a kernel map or K-map to simplify logic expansion. Built the circuit using a logic gate and or not. Simulate the circuit using software. That's what I already did, and I will show you up. Why it's useful? We can use it in calculators, in digital clocks, or in counters. Actually, we can use it in any device that show number on a screen. As we see here, we have a traffic light or a counter in a traffic light that shows a 7-segment number. Into the introduction, digital electronics, displaying numerical value is an essential function in many devices such as calculator, digital clock, and like what I already said. So let's jump to a software to show you the work what I did. I have a simple simulation for a 7-segment display. Here is the display we have, and when I click to the switch here, we show the number 1 in the display. If I want to display the number 2, I should click the second switch as like that. In the third switch, we don't have a third switch for it. So what we should do is just light the first one and the second one to have a 3, and so on in the all. If we want, for example, number 5, we should light number 1 and number 4 to have a number 5. It's just simple. In this wiring, we should have AND gate, OR gate, and NOT gate. Here is a truth table that shows the right numbers. In the decimal digit 0, so when we should have 0, the all input are equal 0, which is the switches. This is the first switch, second switch, third switch, and fourth switch. In the all inputs are 0 or all switches are off, we have output line, which is the LED. A, B, C, D, E, and F, all of it should be on to show the number 0 in the display pattern. If we want the number 1 in the decimal digit number 1, we should light the first switch. As we see here, it's a C, the first switch. So when we turn on the first switch, oh no, sorry, it's the D. D is the first switch. So when we light up or turn on the first switch, the output line will show B and C as an on LED, which is represent the E and C here, and so on at all patterns or all digits. Here is the same thing, but in explaining more explaining zeros 9 and 0 until 9, which is above the 9, which is 10, 11, or so on, it will be don't care. As we see here, it's just don't care. We don't want it. The result and observation. The circuit has successfully converted BCD input 0000 to 1001 into the correct segment output for the 7-segment display. Each input combination displays the correct digit from 0 to 9. The logic expressions were simplified using kernel map or K-map to reduce the number of gates needed. So we used K-map to reduce it. The simulation in LogicWorks or other software was we used already used LogicWorks, so confirmed the expected behavior. The circuit ignore invalid BCD input like 1010 to 1111. We get back here. So if I turn on the last switch, which is represented 8, the number 8 or the digit 8, it will just ignore it because it's just uh, don't care. I hope the project was very clear, and thank you for watching me.